So a little while back, I talked about the Predictioneers model or the Predictioneers game, which is a way of thinking about prediction and forecasting that was developed by Bruce Bueno de Mesquita. And while I really like the Predictioneers game and the logic behind it, there's something that always kind of bothered me about it, and that is the sort of inherent subjectivity of taking sort of the preferences of different actors or their strength or what they care about and assigning that a number value. And one of the things that always left me a little uncomfortable is, what if I get those number values wrong? What if I'm really not sure? And so as I was thinking about that problem, I developed my own sort of way of dealing with that uncertainty. And I'd like to sort of share that with folks as a way to kind of illustrate a broader technique in general of dealing with uncertainty through a systematic way of quantifying that uncertainty, and then using Excel to help us to kind of get a sense of what that uncertainty might look like. So the way I'm going to do this is I'm going to quickly run through sort of the setup again. This is the case of Russia and Ukraine following the Russia's the ouster of a pro-Russian president by protesters in Ukraine, Russia feeling that it's losing its influence over Ukraine. And the question is, will Russia invade Ukraine? Will they take territory? What's going to happen? And I began with laying out the various possible outcomes in terms of sort of a single dimension, right? And so I thought about this in terms of what Russia might want versus what Ukraine might want, with 100 being Russia gets all of Ukraine and is rebuilding the Soviet Union. And at the other end of the spectrum, Ukraine becomes a full member of NATO and has sort of its territorial and sovereignty and sovereign integrity protected for the foreseeable future. And then within, I sort of placed different possible outcomes that I thought might be more or less favorable to Russia or to Ukraine. And then with the Predictioneers model, you sort of go through for each actor and identify their influence, like how much they're able to apply pressure to a situation. Salience is how much they care about it. And then what's their ideal point? And particularly with this part, I was really uncomfortable because I don't necessarily know what these values should be. I mean, I certainly would think that for Ukraine, the salience of 100 makes sense. This is the most important thing for Ukraine. Its survival and territorial integrity matters more than anything else. But I also put 100 for Russia, suggesting that nothing matters to Russia more than sort of advancing its interest in Ukraine. And I don't know that that's actually true. So even though I sort of put forward what I thought were reasonable guesses, I'm not 100% confident in my numbers. And I wanted a way to be able to deal with that, because when we use those numbers, we calculate out the power score for a country, multiplying their salience by their influence, right? How much you can influence things versus how much you care to influence things, getting a sense of power. And then we weight each country's ideal point by their power and figure out what the overall average is. So it's almost like a tug of war between these different scores. And the prediction I came up with was 80.69, which corresponds roughly to somewhere between Russia gets the Russian areas and retains influence over the rest of Ukraine, and 65, Russia retains influence over a territorially stable Ukraine. So my prediction came out to be is Russia's retaining influence and gets some territory from Ukraine, which actually seems to square pretty well with what we actually observe. So the Predictioneers model is doing pretty well just on its own, but what about that uncertainty? And so the way that I dealt with that is I created this little Excel table, and I put in the values that I was using earlier: salience for each of the three actors, their influence for each of the three actors, and their ideal point. And I have over here the calculation of the power. So Russia's power is E2, which is this value right here, E2, times E8. So this value right here, the 81. And I use that to calculate the total power, just like I did in the previous equation, and to calculate out a prediction. But what you might notice is that I'm using the values in this E column rather than the initial values that I provided. And the reason for that is because I wanted a way to quantify the uncertainty that I had about these values, right? And so as I mentioned, when I'm thinking about the salience for Ukraine, I'm pretty confident in that score of 100, because nothing's going to matter to Ukraine more than its own survival, its own territorial integrity. And so in terms of the confidence, or maybe I should call this my unconfidence or my uncertainty, I put in a 0, which says, I'm fully confident with that. We don't need to adjust it or change it or rethink it in any way. But maybe I'm a little fuzzy on Russia. And so I put a 5 in there saying, maybe it could be a little lower, it could be a little higher, I don't know. And then for the West, I had even more uncertainty. I certainly believe that the West cares some about the future of Ukraine, but because Ukraine's not currently a part of NATO, it's uncertain that, that the West is going to be willing to wage a full-out war in Ukraine's defense. So again, just higher values representing greater uncertainty that I have about that. And then I have this randomizer. And all this really is just using Excel's random number feature, which generates a random number from 0 to 1. And I multiply it by 2 and subtract by 1. So it ends up being half the time it's a positive number up to 0.5, and half the time it's a negative number, or I should say half the time it's a positive number up to 1, and half the time it's a negative number up to -1. And then I multiply that randomizer times my confidence and adjust to make sure I'm not sort of going over the bounds, right? If it's greater than 100 or less than 0. And so I'm getting an adjusted value based on a random number and my confidence. But that doesn't actually seem on its own better than anything else, because really all I'm doing is I'm just simply throwing a random adjustment to my original number. And so I added in an additional step, and that is I wrote a really quick macro that would take whatever prediction I got from this set of information, and I would pick that up, and I would click transfer, and it will move it to sheet 2 and put it somewhere in here. I think it ends up landing right there. So when I hit transfer, that 81.456 gets moved to 81.456. Is that useful? Maybe not on its own, but because computers are able to do these sort of calculations very quickly, I can actually quickly generate many, many, many different calculations using different random numbers. And so I'm going to click this transfer 1,000 times, which just simply loops that process of picking up a predicted value based on random numbers and moving it and storing it in another sheet. And so I'm going to click transfer 1,000 times, and my screen's flashing very quickly. Hopefully that works pretty well with Zoom. I haven't figured out how this will record and all, but as it's working, it is generating 1,000 different calculations, 1,000 different measurements. Sometimes the values are going to be higher, sometimes the values are going to be lower. It's all based on that randomness. And what's going to emerge out of the other side of all of that is a picture of how good of a job our initial measures are doing. And if our initial measures are off, how much might they be off by? And so you'll note that there's the average prediction, which is sort of the full range of things, but then there's also the minimum prediction and the maximum prediction. So we can look at those 1,000 various different calculations and sort of see what the end result is. Take just a second to wrap this up. I should point out that this is a fairly common technique used by statisticians doing forecasting. It's not unlike the presidential forecasting model that Nate Silver uses, where he puts in some initial information, puts in some uncertainty around that information, and then just sort of calculates what's the probability that, one state's election count might come in a little above the polls. What's the probability it might come in a little bit below? Calculates that out for all 50 states, and then just runs it over and over and over, figuring out what happens with different random selections, figuring out what's the likely distribution of the election, assuming that some states are going to come in a little high, some are going to come in a little low, but there's going to be sort of a random component behind all of that. Okay, so we finished up, and now I can sort of flip over to sheet 2, possibly. I can't, it's locked up on me. Yep, and I can see my 1,000 different computations of all of those different possible scenarios, and I built in some statistics to look at that column and sort of see what I have. And so while the prediction average is about 79.9, so just a hair lower than what I had before, what it suggests is that things might go as low as 68, based on the uncertainty that I put in, and it might be as high as 93. And what I can do is I can take that information and I can go back to my original sort of range and say, okay, so at the high end, it might be as high as 93, which would be Russia getting large chunks of Ukraine and retaining influence over what remains. And as low as 63 might be that Russia gets no territory, but it remains influential in Ukraine as a powerful neighbor with some say over its future. So again, it gives us a sense of, if there's uncertainty, what might that look like when we're thinking about our forecasts? Again, this isn't something that is part of Bruce Bueno de Mesquita's sort of predictioneers model, but I think it's a useful addition, and it also hopefully is a tool that folks can use and think about for how you might build a prediction or a forecast, and how you might test or check the robustness of those forecasts.